Hi, in this problem we're going to get more practice working with Poisson processes. And in particular we're going to look at how to merge two Poisson processes and then think about where each arrival in the merge process came from. In this problem we have a service station that services jobs of two types. Type A jobs, we're told, arrive as a Poisson process with a rate lambda A equals 3 jobs per minute. Type B jobs also arrive as a Poisson process with a rate lambda B equals 4 jobs per minute. And we're also told that these two Poisson processes are independent. Part A is looking for the PMF expectation and variance of the number of total jobs that arrive in any 3-minute interval. Let's define a random variable for that. So let's let n be the number of total jobs in 3 minutes. We know that for a Poisson process, the distribution for the number of arrivals in any given time interval tau is given by a Poisson distribution. But we have to do a little bit more in this case because we're looking for the number of total jobs. And here we're only given Poisson processes for the individual types of jobs. But because they're independent, what we can do first is merge these two processes. And what we'll get is a merge process with a rate lambda that's equal to the sum of the two individual lambda A and lambda B. So what we get is total jobs arrive at a rate lambda equals to 7 jobs per minute in this merge process. Now what we can do is apply the Poisson distribution to this merge process. So in general, the Poisson distribution is equal to lambda times tau to the n times e to the minus lambda tau over n factorial. In our case, lambda, we just said, was 7. Tau, we're given that we're interested in a 3-minute interval, so tau is 3. So let's substitute that in, and we get lambda times tau is 21. So we get 21 to the n times e to the minus 21 over n factorial. And we should specify that this is valid for n equals 0, 1, 2, and so on. The last part of this, part A, asks us for the expectation and the variance. We know that the expectation of a Poisson random variable is equal to lambda tau. In this case, lambda tau is 21. We also know that the variance of a Poisson distribution is again equal to lambda tau. So the variance of n is also equal to 21 here. Okay. In part B, we're told that we have a 10-minute interval, and we know that there were exactly 10 total jobs that arrived in this 10-minute interval. And what we're asked to find is the probability that exactly 3 of these 10 jobs were of type A. So in order to do that, let's go back to our merge process and consider any arrival in this merge process. Let's say this one. We know that the probability that any arrival in the merge process came from type A, given that there was an arrival, we know that this probability is equal to this ratio, lambda A over lambda A plus lambda B. And so in this case, we know that given that there was an arrival in this merge process, so there was some job of either type that arrived, the probability that that job was of type A is 3 over 7. And the other thing that we can note is that suppose that we consider now another arrival in the merge process. We also know that whether or not this arrival was of type A is independent of whether or not this arrival is of type A because of the fresh start property of the Poisson process. So after this arrival arrives, the process starts anew. And so what happens here is independent of what happens here. Now, part B, remember, is asking us for the probability of exactly 3 type A jobs out of 10 total jobs. Now, we can think of this from the lens of successes out of total number of trials. If we view an arrival coming from type A as a success, then we have what we're looking for is the probability of 3 successes out of a total of 10 trials. And that sounds like a binomial. And so that is exactly what we're going to do. We want to find the probability of 3 successes in 10 trials. And we just calculated that the probability of any given trial being a success is 3 over 7. And so by using the binomial, we know that this is equal to 10 choose 3 times 3/7 to the 3rd power times 4/7 to the 7th power. Now, part C is telling us that suppose we started at some time 0, and we focus only on what happens after this time. We want to know what is the distribution, the PMF, of the number of type B arrivals until the first type A arrival. Everything is relative to after some arbitrary time 0. So let's say this is, again, our merged process. These are the arrivals in the merged process, and each one can be of either type A or type B. And so let's say, for example, say this is where the first type A arrival occurs. Well, what that immediately tells us is that these 3 prior arrivals were all of type B. And so what we can take away from this is that once we know when the first type A arrival occurs, that tells us immediately how many type B arrivals there were before, up to that first type A arrival. And that's exactly the quantity that we're trying to find the PMF of. Okay, and if you think about it, what we're looking for now is related to the number of arrivals until the first type A arrival. And that sounds like a geometric. The number of trials until the first success, where success now we can think of as a type A arrival. Okay, so let's define a random variable again, k. K is the number of B arrivals until the first A arrival. That's what we want to find. And the PMF of K, this is the probability that there are K arrivals, KB arrivals, up to the first A arrival. And what we just said is that that is equivalent to being that the first A arrival occurs on the K plus 1, occurs on arrival number K plus 1. So if this is arrival number K plus 1, then we know that there were exactly KB arrivals prior to it. Okay, so what is the probability that first A arrival is at K plus 1? Well, that means that it's going to be the geometric, because we need K failures followed by a success at the K plus 1 trial. So we need K failures, meaning that the first K arrivals must all have come from type B, and we can do a similar argument here to show that for any arrival, the probability that's from type B is just lambda B over lambda A plus lambda B is 4 over 7. So we need the first K of those to be of type B, and then we need the K plus 1 arrival to be of type A, and that's with probability 3 over 7. And so that gives us our answer. And this is valid for K equals 0, 1, 2, and so on. Okay, and so in this problem, we got some more practice with Poisson processes, specifically thinking about how to merge processes and then taking the merge process and calculating probabilities related to going back to the source, the origin, whether it was from lambda A or lambda type A or type B. And we saw that there are some connections that we can make to the binomial and the geometric in this case. So I hope that was helpful, and see you next time.